guys. Okay, so we're doing our very last section, 8.1, L'Hôpital's rule. So it's literally called L'Hôpital. So L'Hôpital's rules. So first, you're actually going to find the limit as x approaches 2 of this, and then you're going to pause the video. You're going to make sure you do this. Don't just copy it. Sometime you're going to pause it, and then you're going to start again. Here we go. You get something like that. So your final answer, sorry, I'll focus. Okay, your final answer is 12. So check out your work, make sure you can do SOAP. Final answer 12. All right, we're good with that. You are going to complete this section, which I know I blocked out. I'm not actually going to show you the answers to this until tomorrow because it gets a little bit complicated. But what I do want you to do with your friends is decide which ones definitely have an answer and which one are you not sure about. So there should be 7 that you're not sure about. If you have more than that, we can talk about it tomorrow. If you have less than that, then you might be wrong. Okay? All right. So back to the ones that don't make sense or indeterminate form. One of the indeterminate forms is actually 0 over 0. So when you have 0 over 0, normally you got to factor the top, factor the bottom, or there's some sort of special rule with sine and cosines and things like that, and you did that last night for homework. So when you have 0 over 0, you can factor or you can use special rules, or you can use L'Hôpital's rule. So L'Hôpital will only work, let me stress this, it will only work if it's a fraction and you can use it. In other words, if you can get an answer that's like an actual, like a 4 or a 0 or a -2 over 7, that's an answer. So if you get 0 over 0, that's when we use L'Hôpital, and it has to be a fraction. Okay, so how it works is you get something like this, which is obviously a fraction. What you can do is you can take the derivative of the top, and then you can take the derivative of the bottom, and then you can go ahead and plug in that x goes to a. So you can plug in that limit and see what happens. So here's the original problem. And then that gives you 0 over 0. So every time you use L'Hôpital's, I want you to write L'Hôp, like for L'Hôpital's. Or you can write an H or something, but you're going to tell yourself that you're using L'Hôpital and how many times you're using it, because sometimes you got to use it multiple times. So in this case, we're going to use it one time, because you can only use it one time at a time. So once at a time, sorry. So then use L'Hôpital's on the top. You get 3x squared minus 0, so 3x squared. On the bottom, your derivative is 1. And then now you plug in the 2, and you get, 12. So that's how L'Hôpital's works. I know, you're really mad at me. I haven't told you before. You cannot use L'Hôpital's if it doesn't apply. So think of it as, this looks like hospital, right? It's a hospital. So think of medicine. If you were to take medicine and you're sick, it makes you better. But if you're all better and you try to take medicine, then sometimes you're not good anymore, and then you have other problems. So you can't just keep taking the medicine. There's only a course of 10 days for antibiotics or whatever it is. So you cannot use it if there's an answer. You'll get the wrong answer. So for instance, what happens is people just go overboard and they're like, oh, the answer is, I'm not sure what the answer is, I'm just going to do it again until it looks really easy. But sometimes you're missing an answer. You're missing the answer that's infinity, or you're missing an answer that's 0, because those are real answers. All right, so moving on to examples 1 and 2. So you can see, I think, so you plug in 0, and you get 0 on top, 0 on the bottom. So that's no good. That's indeterminate form. So we use L'Hôpital's. I tell myself I'm using L'Hôpital. I take the derivative of the top. The derivative of 2 to the x, you got to look at your green paper for the resources, is 2 to the x ln 2. The derivative of -1 is 0. The derivative of x on the bottom is 1. All right, now I plug in my 0. And then when I plug in my 0, the limit goes away. 2 to the 0 power is 1. So 1 over 1, ln 2. ln 2 is our answer. That's how it works. Example 2. You plug in infinity. You get e to the infinity, which is infinity. You get infinity squared, which is infinity. That is a very weird case of infinities. This you cannot use the principle of dominance. It just doesn't work. So we have to use L'Hopital's. This is not a 1, by the way. So this was not like x squared over x squared. So this is different. So that's why we have to use L'Hopital's. So I use it once. On the top, I get e to the x. On the bottom, I get 2x. I plug it in, and I get infinity over infinity still. That's no good, because what I can see is this infinity is possibly smaller than this infinity, but I still need to check by doing L'Hopital's. So this happens, no good. I do it one more time. So I did it once, now I do it again. The derivative of e to the x is still e to the x. The derivative of 2x is now 2. And then you plug in infinity, the limit goes away. E to the infinity is infinity, divided by 2 is infinity. So my final answer is infinity. Okay, example 3. I'm going to move it up a little bit. Here we go. So plug in infinity, and then you get infinity on top. Plug in infinity, and you get infinity on the bottom. It's not the same kind of infinity. It's not like x squared and x cubed or whatever, so we can't use principle of dominance. I use L'Hopital's. L'Hopital's on top gives me 1 over x. Sorry, derivative on top is 1 over x. The derivative of the denominator is 1/3 x to the negative 2/3 power. All right, before anything else, I simplify this. So I'm simplifying, I'm not like using L'Hopital's. So from here is my next step. What happens here, let's see, the 3 is it's basically something divided by 1/3, so the 3 goes on top. And then this x right here, it's 1 over x divided by 1 over x to the power of 2/3. So really, it's this fraction over here. This can be simplified even further. There's an x on top, there's an x on the bottom. This has a power of 1. So really, this is 2/3, this is 3 over 3. So then you have an x to the 1/3 on the bottom. From here to here, all we did was simplify. Now you plug in your infinity, and then you get 3 over infinity. Any number divided by infinity is 0. So our final answer is 0. We only used L'Hopital's once. This is one of those examples where people will want to use it again because they get something like this and they're like, oh, that's crazy. But you have to simplify it and then plug it in infinity and then see what you get as your answer. Okay, last one. I know it looks kind of scary. All right, plug in 0, you get 0 over 0. That's no good. So L'Hopital's. The derivative of tangent is secant squared. Derivative of x is 1. On the bottom, you get 3x squared. You plug in 0, and you still get 0 over 0. So we do L'Hopital's again. So that's 2 times. You get the derivative of the top. This is actually the quantity squared. The 2 comes forward, and then you have a secant x to the first power, and then the derivative of secant is secant tangent. That's why this is secant squared x tangent. So the derivative of this is this. If you write it out really nicely, eventually you get this. The derivative of 1 is 0. That's why there's no more number here. Derivative of 3x squared is 6x. And then the 2 and the 6 kind of divide away. I'm left over with a 3. I try to plug in my 0. I still get 0 over 0. Oh my god, I'm so close. But I have to do L'Hopital's one more time. Alright, I know, you love this so much. But now you have to do a derivative of a product. So product rule, I'm going to let you like think it out as you're doing it. Ask your friends. But product rule, derivative is right here. On the bottom, 3x becomes a 3. Derivative of 3x is 3. And then I know that I'm going to have a 3 on the bottom, so this should work out. I plug in 0. Right here, secant of 0 is 1. Secant of 0 is 1. Well, squared is still 1. So then here's my 1 and my 1. The tangent of 0, and then this multiplied give me 0. On the bottom is a 3. So I really have 1 over 3. That is not 0 over 0, so that is my answer, 1 over 3. Final answer. Okay, your homework is, so for 8.0, you checked with a friend. For homework 8.1, it is, I will show you, worksheet 47, which is the back of this paper. On the back, here's your worksheet 47. You are going to use this as your, book. So write the problem, use L'Hopital's. It gives you like an example of how to do it. And then the answers are all on the bottom. And I showed you what the answers are. All right, so give it a try. And then I will see you tomorrow. And then we'll talk about these problems in the middle. And then we'll continue with L'Hopital's. Have a good day, guys.